Dear third prep, today we will continue the distance between 2 points, which is lesson 5, unit 5, lesson 1. We took last time that the distance between any 2 points, x, a and b, x minus x all power 2 plus y minus y all power 2 inside a square root. Here, if he told you, or if he asked that to prove that this triangle, or to find the type of the triangle according to its sides. If I have a triangle, I have 3 equal sides, so it's an equilateral triangle. I will find that AB equal BC equal AC. So if you prove that AB equal BC equal AC, you have proved that this triangle is equilateral. The second type, which is I have 2 equal sides and 1 different, which the isosceles triangle like this. I have AB equal AC not equal to BC, or AB equal BC not equal to AC. Any 2 equal sides and different side, it's called an isosceles triangle. The third type, it's AB not equal to BC not equal to AC, 3 different sides. This is a scalene triangle. For example, he will tell you that to prove that this triangle is an isosceles triangle. This is our rule to find the distance between any 2 points, and here to prove I want to find 3 distances, or the 3 sides of the triangle. I want AB, BC, and AC. AB is 3 minus 5 all power 2 plus 3 minus 9 all power 2 equal to square root 10. BC, 5 minus negative 1 all power 2 plus 9 minus 7 all power 2 equal 2 root 10. AC, 3 minus negative 1 all power 2 plus 3 minus 7 all power 2 equal 4 square root 2. Now I have 2 equal sides and 1 different, so this triangle is isosceles. It will be written like this. Since AB equal BC not equal to AC, therefore triangle ABC is an isosceles triangle. Again, the type of the triangle according to angles. He can ask you to find that which is right or acute or obtuse. Here, I will use the squares of the side. If you found that the smaller 2 sides plus each other concentrate, I will take the smaller 2 sides, squares and plus each other. If I found that the smaller 2 sides is greater than the square of the greater side, this triangle is acute. So I will go with AB and I bring AB and AC and BC as we did in the last example, but we will square them and take the smaller 2 sides together. If the sum here is greater than the third, so this triangle is acute. And if we found that the smaller 2 sides square, their sum equal AC power 2 equal the greater side, this is right angle triangle like this. And if we found that the sum is smaller than BC, then AC, this triangle is an obtuse triangle. For example, prove that the triangle whose vertices A 3, 2, B, negative 4, 1, C, 2, negative 1 is right angle triangle and find its area. Again, I will use the rule of the distance to find the 3 sides. I know that it's a type according to angles, but now I will identify the type according to angles using the sides. I won't talk about the angles. I will not find the angles, and these numbers are not the angles. These numbers or the squares of the sides are only to define or to determine the type. Here, AB, it's 3 minus negative 4 power 2, 2 minus 1 power 2 equal 5 square root 2. BC, negative 4 minus 2 all power 2 plus 1 minus negative 1 all power 2. First, we will find AB power 2, put it inside a bracket, equal 50. Again, AC, 2, 4 minus 2, 1 minus negative 1, power 2, 2 square root 10. We will find BC square equal 40. AC, 3 minus 2 and 2 minus negative 1 equals square root 10, power 2 is 10. So when you find or determine the type according to sides, these steps till here is enough. Now I have 5 root 2, 2 square root 10, square root 10. This triangle is scalar. But if the type according to angles, I have to square the sides. After finding the three sides, square them, a power 2, AB power 2, BC power 2, and AC power 2. And this number what we use to determine the type according to angles. Now, I have 50, 40, and 10. We will take the smaller two sides, BC power 2 plus AC power 2. The smaller two sides equal 50, and the greater side is 50. So, since in the sum here equals the other side's power 2, so this triangle is right. If you found that the sum of the squares of the two sides equal the square of the greater one, this triangle is right. Right at what? This side, which is alone, is AB, so this triangle is right angle at C. If I draw it, I will find that AB, which is the longest side, is the hypotenuse. So the right angle here is C. So the base and height of the triangle, because he asked about its area, it will be the smaller two sides. And this use the side itself, not the squares. The square, I will use it only till this step to prove that it's right, acute, or obtuse. After that, no, we will use the side itself. So the base and height here, the smaller two sides. We will make half times 2 root 10 times root 10 equals 10. Again, so now in the triangle, I have two types according to angles or according to sides. According to sides, I will find the three sides and determine the type. That's the three sides only. You are right, the three sides are equal, is equilateral. Two sides equal one different. Isosceles, three different sides is scalar. But to define or determine the type according to its angles, we have to find after that the square and make the smaller sides plus and compare it by the third side. Now, in the quadrilateral, I have 4 special quadrilaterals, which is parallelogram. If I have a parallelogram here, ABCD, we will find that the opposite side of the parallelogram are equal. AD equal AC and AB equals CD. Okay, so if you prove that each two opposite sides are equal, so this figure is a parallelogram. We have to find its 4 sides and take each two opposite sides together. The same here done in the rectangle. If I have a rectangle ABCD, I will find also that each two opposite sides are equal. So I will find here that AB equal DC and BC also is equal to AD. So the parallelogram and the rectangle are like each other. What is the difference between them? The difference here in the diagonals. The diagonals of the rectangle are equal in length. So I will find that AC equal BD. But in the parallelogram, the diagonals are not equal. So here I have to prove in the parallelogram or rectangle, I have to find the 4 sides and the 2 diagonals. If each two opposite sides are equal and the diagonal are equal, so this is a rectangle. If each two opposite sides equal and I have different diagonals, so it's a parallelogram. For example, prove that ABCD are vertices of a parallelogram using the same rule. This rule, I will use it every time to find any distance between any 2 points. So if I want to find any distance, I will use the same rule. AB is x minus x power 2 plus y minus y power 2, 2 square root 17. BC, negative 5 minus 0 power 2 plus 0 minus negative 7 power 2 equal square root 74. CD, every two consecutive letters are side. يبقى AB side, BC side, CD side, and DA side. 0 minus 8 all power 2 plus negative 7 plus 9 all power 2, 2 square root 17. 3 minus 8 all power 2, negative 2 minus negative 9, it will be plus 9 equal square root 74. Now, I will find that 2 root 17, 2 root 17, square root 74, square root 74. Now, each two opposite sides are equal. I found that AB equals CD and BC equal AD. But I have to find the diagonals to know that which is parallelogram or rectangle. AC equal root 3 minus 0 all power 2 plus negative 2 plus 7 all power 2 equal root square root 34. And BD negative 5 minus 8, 0 minus negative 9, side square root 10. So if you found that the two diagonals are not equal in length, therefore ABCD is a parallelogram. These steps we will make it every time to prove any quadrilateral, parallelogram or rectangle, rhombus or square. And now we will talk about the rhombus and the square. The rhombus, it has 4 equal sides. If I have a rhombus ABCD, it has 4 equal sides. So I have here but 2 different diagonals. AB equal BC equal CD equal AD, and its diagonals are not equal. But in the square, I have 4 equal sides also, and the diagonals also are equal to each other. So the difference between the rhombus and the square is the diagonals again. So the parallelogram and the rectangle are the same, each two opposite sides are equal, but the diagonals are different, equal in the rectangle, different in the parallelogram. The same here between square and rhombus. Both of them has 4 equal sides, but the diagonals are equal in the square, not equal in the rhombus. For example, prove that these points are vertices of a rhombus, graph it, then find its area. I will find the 4 equal sides and the 2 diagonals. Okay, we have agreed that every quadrilateral has 4 points and its vertices. We will find its 6 elements, 4 sides and 2 diagonals. Square root 13, BC square root 13, CD square root 13, and AD also the square root 13. So now I have 4 equal sides. This is a rhombus. But I have to find the diagonals. AC will be 6, BC will be 4. Now, if I have 4 equal sides, 2 different diagonals, therefore ABCD is a rhombus. I will graph it. A, negative 1 and 4, B, 1, 1, C, negative 1, negative 2, D, negative 3, negative 1, negative 3, 1. So this is the rhombus ABCD. I want its area, which is half times diagonal 1 times diagonal 2, and I have already found the 2 diagonals. It will be half times 6 times 4 equal 12 square unit. The last thing we will ask that ABC are 3 points belong to the same circle M. If I have 3 points A, B, and C, and I want to prove that they are belong to circle M, I want to prove that the distance between the 3 points and M are equal, which is the R or the radius length of the circle. If the distance between the center and any point on the circle, it has to be equal because all radii of the circle are equal in length. So if you proved that MA equal MB equal MC, so A, B, and C belong to the same circle. You have to remember here that the area of the circle is 2 pi r per 2, the circumference of the circle is 2 pi r. For example, prove that the points A, B, and C belong or lie on the circle whose center is negative 4 and 6, and define its area using pi 3.14. Now, we agree that to prove that A, B, and C belong to circle M, I have to find AM equal to root 5, BM equal to root 5, and CM equal to root 5. So, since in AM equal BM equal CM, therefore ABC lie on the same circle M. So, here I want to find AB and BC and AC. I will use each point with M, the center of the circle. The area, which is pi r power 2, pi here is 3.14 times 2 root 5, all power 2 equals 62.8 square unit. Thank you very much. See you next time, inshallah.